trouble with their air compressor. So just to give you an idea, this is a portable air compressor. It runs on 120 volts, so it's not a, oftentimes you see bigger air compressors that run on 240. That's not how this one works. It's just 120 volt. And basically what was happening was, as you can see with this switch right here, it has an auto or an off setting. When you have it on auto, that's when it runs, and it's kind of like a thermostat. It automatically runs when the pressure drops below some predetermined amount. And in my case, I always leave it on. I just, even if I'm not using the tool, I figure, it could just charge itself back up if it's getting low, if there was like a slow leak somewhere or something like that. And ultimately what was happening, it was triggering a circuit breaker in the house. So what would happen is this motor does not spin. It just made some loud humming sound, just but no spinning, not at all. And that humming was meaning that the motor was not spinning at all. And it was just drawing so much amperage that it would trigger the circuit breaker, and then it would turn off several things in the house, obviously, and I'd have to go turn it back on, and it would just trip over and over and over again. And it turned out this motor just simply was not spinning. So the first suspicion, of course, is that looking at the belt over here, which is in this housing, that maybe the compressor part itself is not spinning. So I took this plastic cover off. You can kind of peel it off, and I found that I could turn the belt. So clearly this was not seized in any way. You could turn it easily enough. So I didn't have any concerns that the pistons were not working inside the compressor itself, and it was really more of a motor problem. Another thing that I did, just to do part of the checking, so when it's in the auto position and the pressure is below a certain value, it will energize this motor to run it, and you can see I have a circuit access here. And when it wasn't working, but it was just doing the humming, I'd set a couple of multimeter leads onto the motor inputs, the electrical inputs into the motor here. And boy, I'd see the voltage drop a lot. Normally it'd be 110 or 100 and whatever coming out of the 110, 111, maybe higher than that coming out of the wall. And it would drop as much as like 105 in the act of straining to start the motor. So clearly, it was really struggling to spin, and it was just drawing a huge amount of amperage, and that's why it was triggering the circuit breaker. You'll notice here, this one has a thermal protection on it. You press that button and it would clear the thermal protection, but that had nothing to do with the problem because the engine, it wasn't even hot because it hadn't been running for very long. So clearly there was something wrong with the motor. It was not the compressor, and the motor wasn't running. So like I said, I did the voltage check. It was coming in low. So when you have this kind of situation, the first thing to be suspicious of is the capacitors. Like many large electric motors, this one has two capacitors. It has a starter capacitor right here, which I'm showing you, and it has a run capacitor right here, which is when the machine is already up and running. The start capacitor is the important one here, and this is in fact the second one that I've replaced on this unit because they do wear out occasionally. Basically what happens is that when it goes into the on position, it's going to charge this capacitor up. You can think of it as like a short-term battery, and this will be able to give an extra jolt to help spin the engine, to spin the electric motor to get it up and running and performing compression, to start compressing. So the first thing to do is to test if the capacitor is bad or not. Unfortunately, these are pretty cheap. They're like $7 or something like that. So I'm going to show you a capacitor check right now. So this is when a good multimeter really comes in handy. This is a really nice one here. I got this a couple of years ago. It's a Fluke 87-5 true RMS multimeter. It's a digital multimeter, so it can do many things. It can check for voltage. It can check. It can do alternating current. It can do direct current, continuity. It can do amperage measurements, all kinds of stuff, and it even has a temperature sensor, which is kind of cool. I don't have it hooked up right now. But in addition to all of this, it can also check capacitance. So let's go ahead and turn the capacitor check on. And if you look closely there, it's probably a little hard to read, so I'll read it for you. It says 0.28 nanofarads, NF. So this is a bad capacitor right here. This is supposed to be, well, let's see what it's supposed to be. It's supposed to be 30 microfarads. So this is basically, a lot weaker than it needs to be. If it was, 30 nanofarads, I think it'd be like 1,000 times weaker than it needs to be. So it's even worse than that. So this capacitor is definitely shot. This is the old run capacitor on this one, which I did replace in the act of fixing this one. So this is a way to measure capacitors and get a good idea if they're working or not. Let's go ahead and check the starter capacitor and see how it works. Okay, I took the starter capacitor off the motor. Now, I know this one's good because I checked it before, but let's go ahead and do a capacitance check. And it's coming in at 195 microfarads, so it's probably a little hard, but there's a U there. 195 microfarads, which, based on the kind of capacitor this is, it's 189 to 227, so it's exactly what we want for this kind of starter capacitor. So the capacitor is good. I'm going to go ahead and put it back on the air compressor. All right, now we're going to try an interesting little experiment. I've hooked the capacitor back up. It's probably a little hard to tell, but its wires are in fact connected back to the motor, but I have these test voltage leads on it. Now this is why it's nice to have, you know, kind of a high-end multimeter. So I'm going to switch this one to alternating current, and it has an auto ranging capability, so it can go from, you know, a few volts up to hundreds and thousands of volts or something like that. I don't remember its exact range, but when the auto ranging is on, it will oftentimes get confused about you know, what it should be measuring. So it can't sense transients really quick, so I have it on 6 volts, 60 volts, 600 volts, so it's in manual. And then now I'm going to set the min-max function. So now it's in min-max. As you can see right now, it's 0.1 volts, so it's not really doing anything very interesting. But let's go ahead. We'll never be able to see it with the human eye, but let's watch it while it tracks the max value of the voltage across this capacitor when I start it. So we're going to go ahead and start it now. Notice how the voltage has dropped. It's like 2.0, 1.7. It's, you know, barely anything. So that's the starter capacitor doing its job. You know, it's basically taking out of the circuit, you know, once it's up and running, and you could hear the air compressor clearly spinning. But watch this when we go to the min-max function. So right now it's on min-max sensing, max, and it did 149.3 volts. So clearly that's higher than what the wall outlet can do. So you can see in that case what the capacitor did is it got charged up and then it threw its extra voltage into spinning the electric motor to bring it up to speed. So how does this capacitor work? How does the start capacitor, how does the motor, the electric motor, know whether the starter capacitor should be used or not? I'm going to show you that next. Okay, I got the capacitor cover back on. Next, what I'm going to do is I'm going to unplug the motor because we should be safe when we are doing this. And what I'm going to do is there's these 4 bolts around the perimeter of the motor cover. I'm going to take those off and we'll be able to look inside, and I'm going to show you the switch that actuates the starter capacitor. So hold on one second while I do that. In this case, my motor, I know this because I already took it apart. This metal piece where it fits on the motor, there's no particular key to orient it in any particular position. So with a permanent marker, I just kind of drew a line across this so I make sure it's aligned. The only reason that's kind of important is this back plate is the same way, and as I slip, I have these, at least my motor has these great big long screws that go in there all the way through the motor, and obviously if they're not aligned, it's going to be harder to connect them. So by drawing that line, it'll be easier for me to have them aligned. So let me go ahead and take this cover off now. All the screws are out. I'm just going to tap it lightly with a hammer and a screwdriver and it'll pop right off. Okay, as you can see, I have the cover off. Now this is what I want you to look at in here. See this little, and of course it's unplugged, right? See this little plastic thing right here? Now watch this. I'm going to push back on it. See that? If you look closely, see those little metal weights right there? Watch. Those little metal weights. So what happens is that when the motor is spinning in faster and faster, these weights get thrown outwards and they pull this plastic disc in. So they get pulled outwards, right? It goes faster and faster. You hear them, they come out and they pull this disc in. Well, what does that disc do? That disc is pressing, see this little plastic arm right here? So when it's not spinning, when it's turned off, you know, or has low RPMs, this is being pressed against this plastic piece here, and there's a connector. It's probably a little hard to tell, but there's a connector right there. So this plastic piece is pressing against the connector, and if you trace the wires, you see this black one, and I know it's a little hard to see in here. You can trace them and see them go all the way up to the capacitor from inside the cover, and ultimately up into here. So this little arm right here, when it's in this position, it's energizing the starter capacitor. Once the motor gets spinning faster, that little plastic thing pulls away and it de-energizes the starter circuit. So I guess one thing to check is if you're not getting, if the starter capacitor is good, but you're not getting any power to it, then perhaps this electrical switch is bad in here. Maybe it's stuck in the, the running position, the high RPM position. Maybe one of these weights came off, I'm not sure. But in any event, that might be something to check. I'm not sure that all motors are the same, but this one certainly energizes the starter capacitor based on the RPMs and these little weights slinging it out and pulling the disc in, which de-energizes this particular little arm that goes to the starter circuit. So that's basically what I learned. In my case, I'm not 100% sure what was wrong with the air compressor. I took all of this apart. I took this other end off here, and there was a great big wasp nest in there. I don't know if that was shorting out some of the circuitry or not. It didn't really look like it was doing very much, to be perfectly honest, but nevertheless, the motor definitely was not running. It would just go, and it wouldn't spin the belt at all. It wasn't like, when I say not spin, I don't mean it was spinning slow. It was just, just nothing. I mean, just no power at all. I could very carefully, of course, with it plugged in, I was trying to, help it spin by getting it up and moving, and it basically did nothing. So it was really something to do with the starter capacitor, or something in the windings was just not energizing it. And so now I'll keep an eye on this, because I'm wondering if ultimately this switch is bad and maybe it got frozen in the run position and it was not energizing the starter capacitor. I didn't do the test that I just showed you now, before it was bad, so I didn't check if the starter capacitor was being energized. But if I was trying to debug that switch, it would be a good thing to see if you ever see anything above 120 volts or something like that when you're checking the capacitor. So you could have a good capacitor, but if that switch is not working, you're not going to see the voltage there. You're just going to see 1 volt or 0.1 volts or whatever it was, something really, really low in an unenergized way. So that was that. So ultimately, my air compressor is now running perfectly. I hope this video was instructive to you. A good multimeter like this, like I said, a Fluke 87.5, it's about a $300 multimeter, but that min-max function, the capacitor checking functions, and a million other functions that it has is really good for, debugging some problems with, in this case, an air compressor, but for other things as well. I hope you found it informative, and good luck if you're trying to fix your air compressor. Bye-bye.